so so thank you, Hongpai. It's my pleasure to introduce the sub-project. From the point of Professor Bornstein's scientific conception and practice. Firstly, I would like to thank all my collaborators. Professor Bornstein, in the year of 2009, he had the first visit to IUM, to Beijing, and in the year of 2011, we have the joint international workshop on urban weather and climate with Fei and Su. And in the next year, we have the Bob, as the IUM distinguished scientist, and he has two visits. It's about 2 months per year to IUM, and from the year of 2014, we have the first workshop on the sub-project, and on the following years we have 7 workshops, and in the year of 2018, we have the 6th workshop, and so in the year of 2019, in June, we have a working group meeting in IUM. So it's picture here, it's Hongpai and Deb and Bob, and this guy is Michael. And from the year of 2020 to 2022, we have online meetings, and in this year, in this November, we'll have the meeting. We'll have the on-site meeting in Beijing. And then, so Professor Bornstein in IUM, so firstly, he teach in the year of 2012. They teach the mesoscale meteorological modeling class for 15 days with 50 students, and in the year of 2016, he gives urban forecasting mini class for 2 days with about 100 students, and he also mentor graduate students and IM staffs, and he also is the most important one is scientifically organizing for the sub-project, and so for this project, so firstly, Beijing is a city with many population, and there are many floods. Now cause very more frequent disasters. So we are needed to, as a public and the government, need us to improve our forecast and need some suggestion for the measures to reduce the future losses. So we need to understand how does the city of Beijing impact rainfall, and how does it impact the fog and haze. So through the urban thermal and dynamic and aerosol effects. So the science objectives is to promote the international research to improve the understanding and of urban weather via field study and workshops, and to evaluate and improve the high resolution model, and to enhance the urban weather forecast utilities, and to understand the thunderstorm and winter aerosol impact under the Beijing urban terrain and convection and aerosol interactions. And so Professor Bob is the chair of the IAC International Advisory Committee for this project, and this figure shows the observational net. So the networks, we have the weather radar. We have the weather radar and the wind profile and the aircraft for the and the towers, and the AWS station, and the thermometers. So during the observation experiment, we have more 10 thermometers and some expand radar and GPS soundings. So this figure shows the distribution of these 10 kilometers and other lidars and Doppler lidar. And we use a small GPS sounding at 3 sites every 3 hours, using 3 sites, and we use a dual lidar transactions along the fourth range road. So we also focus on the effect of urban canopy on the mixing. So it's similar to the cloud canopy but more complicated, and the HOST hypothesis can be used to explain the observed momentum and heat transfer in urban. And we estimate the PBL depth using the Doppler lidar observation, using the TKE from the lidar, and then we can get the PBL height in daytime and nighttime according to the turbulence. So we also can see the big difference of urban flow is up to about 3,000 meters, and the mixing area heights according to aerosol is from 700 meters to 1,400 meters. And we also to improve the urban model with the surf data. For example, we work with Professor Hongkai to improve the cooling tower scheme, to improve the modeling of latent heat in urban area. And we also focus on the urban impacts on rainfall. From the observation, we can see if we have the weak urban heat island, and then we can get the rainfall enhancement is outside of city. And if we have the strong urban heat island, and the rainfall enhancement is in the urban center, and the magnitude is about 75%. And we also do the case-based mechanism analysis for these two kind of cases. One is urban impact rainfall is a bifurcation, and one is rainfall enhancement for these two kind of cases. So based on the observation and the research on urban boundary, we developed the RMAPS model system. It's for the operational run. We focus on from 0 to 24-hour forecast with high resolution and high frequency update cycling, and to emphasize the assimilation and blending of local data and the integration of multi-physics, include for the short term, for nowcasting, for urban, for chemistry. It's for integration of the observation and modeling results. It's operationally run in Beijing Meteorological Service. For the urban model, we developed the urban dataset and using some new developed new parameterization scheme. Firstly, we derived urban canopy parameters using the building morphological data, and also improved the urban hydrological processes. From these 4 parts to improve the numerical simulation of the latent heat, and simultaneously we can improve the sensible heat, flux from the surface. And it's about the new cooling tower scheme is incorporated to the BM and BP scheme, and we also developed a new gray zone urban PBR scheme. It's a blending of the TKE scheme and the area scheme, and it's coupled with the urban canopy model. So it's done by Ms. Yu Huanli. And the urban service, so based on the RMAPS model, including the nowcasting of urban precipitation, urban flood warning, and the short-term forecast for urban weather, and and energy consumption. So it's based on the BM model using space cooling and energy consumption, and also the urban climate map for the urban planning is based on the urban modeling. So from the year of 2019 to 2022, we are focused on the fine-scale forecast for the complex terrain, including these two parts. One is from observation. We use three Doppler lidar to observe the 3D PBL wind. With collaboration with Professor Hong, and we real-time run the LES model on the horizontal resolution on the horizontal grid spacing of 100 meters, and serve the Beijing 2022 Winter Olympics, especially for the wind in the complex terrain. And so from this year, we focus on the severe convective storms in complex terrain and urban environment, including the field campaign and the fine-scale urban forecasting, and especially for the urban canopy model and urban hydrological model on the scale of 1 kilometer and below, for example, 100 meters. So we do in the next 4 years with Professor Bob Bornstein. Yeah, so that's all for my talk. Thank you for your inspiration and for your guidance, for your mentor. Thank you.
I think we have time for more questions here. Well, I see tremendous progress in last time we spoke, so I'm glad that the work have continued all across. This is very good.
And Bob has questions.
Bob, you want to comment?
And a wonderful presentation. Every one of them has been wonderful so far. I'm really impressed with all the work I've done.
Yeah, thank you. Thank you, Bob.
Thank you, Mio. Thank you very much.